right, so now we have three for the price of one. We have Charing, Justin, and David, who are going to talk to us about snapping and scaling beautifully, designing apps with adaptive layout in Windows 8, and thinking beyond the 9-inch display.
Cool. So we're actually a bit early, but I'm just going to go ahead and start. It's always nice to give time back if I do end early. So my name is Charing Wong. I'm a program manager on the user experience team on Windows. And I'm here actually with my colleagues David Washington and Justin Cooperman to talk to you about how you can design your app to snap and scale beautifully. So we're super excited to be here on behalf of our teams. My particular team worked on the switching and multitasking experience. So in Windows 8, how you switch between apps, how you resize apps, how you snap apps, and how you rearrange apps. And so let's get started. So why do you even care? Like, why would you want to listen to me for the next half hour? Well, the thing is, Windows 8 is for all PCs. So this is a huge opportunity. Just imagine all the Windows 7 devices out there right now. Windows 8 are going to be on tablets, desktops, laptops, all-in-ones, slates, you name it. That means your app has an opportunity to be in all of these devices. And what we want to do here is to make sure that you are successful on all of these devices so that you can reach as many users as you can as possible. And so, before we go deep, I just want to talk about some basics. First of all, view states. So view states is a concept that we introduced in Windows 8, is what we use to describe the shape of your app. It has information to help you decide how you want to lay out the content within your app. And so in Windows 8, there are 4 view states. Here are 2 of them. So these are what I like to call the full screen view states. This is when your app spans edge to edge in both directions. The full screen landscape one is one we're all very familiar with. If the user rotates a slate device or if a desktop user has a portrait monitor, then your app can also be in a full screen portrait view state. Then I have what I like to call, anyway, the multitasking view states. So these are the view states that lets you be visible alongside another app so that the user can multitask with 2 apps. And so the view states are snapped and filled. The snap view state is a fixed width. It's always 320 pixels wide. And the fill view state is whatever width is left over on the device next to the snapped app. And so for my particular session of this talk, I'm going to be talking about one particular view state, which is the snap view state. The reason why we're focusing a bit on this is because this one tends to be a bit harder to grasp and is often a bit misunderstood. We will not be going too much into portrait, but a lot of the principles and guidelines that I'll be covering, as well as David and Justin will be covering, will still apply in portrait. And so, what is snapping? So it's really simple. Snapping is what lets users see 2 Metro apps on screen at the same time. I could be watching a movie while I'm reading news on the side, or I could be reading news and watching a movie. I could be chatting with a friend while I'm doing email, or I could be doing email while I'm chatting with a friend. I could even write and be productive on my Notes app and still have my People app on the side with my newsfeed kind of showing what's going on with my friends. Or I can make the newsfeed app bigger and still have my notes on the side. What I'm trying to illustrate here is that in Windows 8, it is super easy, very, very easy for the user to resize apps, rearrange apps on screen. And so the fact that your app supports a snap state will make your app super valuable to the user because it enables a whole host of multitasking scenarios that weren't there before when you're just using the app, one app that bleeds edge to edge. Cool. And so now that we talked about how you think about what snapping is about in Windows 8, the next question you might ask is, how do I think about this state? And this is one that I think that is often misunderstood or a bit harder to grasp. So I just want to talk to you how we think about the snap state. Well, we think about it as just a resize. It's literally the same app, but smaller. And just like a resize, we expect this to happen to your app at any time, at any given point. Like your app can be resized by the user on any page at any point within your app. And so I really want you to internalize that, because I feel like sometimes this message doesn't come through when we're talking about it. And so since it's the same app but smaller, what are some principles that we can follow to make sure that this is how we see the snapped app? So the first one is we want to make sure you preserve context and state across resizes. This is especially important when the user can resize you at any time. You don't want to be losing context and state across resizes. That's very unexpected and frustrating for the user. And secondly, because it's the same app, we do want to strive for feature parity. It would be very weird for the user if suddenly features fall off or buttons go away or suddenly I can't do something because my app is smaller. In general, we want to say that we want to support all scenarios in the snap view and really only take away things if you absolutely have to. What we don't want the snap state to be is a very separate, isolated, standalone gadget that you put on the side. We don't want it to be that. It is the same app but smaller. Because a lot of times the user may not be snapping you because they actually want it to snap you. They may snap you because they may be making the other app bigger, and as a result, you got snapped. So let's look at an example of what we mean by preserving context and state. So imagine I'm writing email to Kim at Abercrombie about dinner this weekend, and I just have my newsfeed on the side because I like to monitor what's going on with my friends. And something caught my eye in the newsfeed, and I want to make it bigger. I expect that when I resize this, and it's very easy in Windows 8, that my half-written email to Kim should still be on screen. What I don't, I would expect to still be able to type in here, and if I really want to send it now, I can go ahead and do that. What I don't expect in this case is if when I make my newsfeed bigger, that mail decides to navigate me to a completely out of context page, like the inbox view, and lose my half-written email. I would be very frustrated by that. And so don't do it. So that was just one example of context and state that you want to preserve. Here are some other examples of pieces that you might want to preserve across resizes. As I mentioned, content, page, and location should be preserved across resizes. In general, we really don't want you to be navigating to somewhere new just because I've resized. And this is true not just for snapping, but across rotation and transitioning between different view states. Selection, this tends to apply with apps that have long lists of content that are selectable. If the user has done the work to make selection, and maybe they may just snap it for a while to look at what else they need to select, that selection should be preserved across resizes. Scroll position. So this is, again, more applicable to long apps with a lot of content, long lists of content. If I'm in the 5th group within the app and I resize, it would be really nice if I don't have to repan all the way back to the 5th group after the resize. And finally, text input we saw in the example. If the user has entered text input, we really shouldn't throw that away just because the user is in a different view state now. Yeah, so resizing should not lose a user's work. Try hard to really preserve context and state across snapping, unsnapping, and just resizing into different view states in general. Now, the second principle that I covered was, that I talked about initially, was striving for feature parity. What this means is that we want features to always be there, generally always be there. And now I know the snap view is a bit interesting because it has such a small amount of kind of screen real estate. And so if there are scenarios that you tried hard but doesn't fit, we recommend you to leave the entry point into that scenario and then grow bigger than to omit the entry point completely. And I will have an example that kind of covers this shortly so that it's a bit more clear of what I mean by that. And so, okay, this is a sample news app to demonstrate what I'm going to talk about. So I've learned that from using the sample news app in the full screen landscape view, that whenever I can select pictures within the article, and when I select pictures, I will see an app bar that comes up with a list of commands, one of which is to save that picture onto my computer. Now, if I decide to snap the news app because I want to read news while doing something else, like email, I would expect that when I select the picture, the same list of commands should come up. There's no reason why the same list of commands shouldn't. And I would be very surprised if the list of commands doesn't come up, or if I can't select the image. So that is one way to strive to have feature parity. Now let's go back to the full screen landscape view state of this app. Now when I select a picture, I see the save image command. When I invoke the save image command, I'll get a Windows 8 file picker menu that lets me then choose where to save that image. Now this is kind of interesting because this file picker is not available in the snap state. So as a designer, what am I to do? Do I remove this button because I'm like, well, it doesn't work in this state, so maybe I should just remove it, or what else can I do? Our recommendation here is that Windows 8 actually gives the capability to apps to go big, so programmatically become bigger. And so our guidance here then is that if something really doesn't fit and you've tried hard to do this, then it is better to leave the command in the app and then automatically go big. So in this particular example, when the user presses the save button within the app bar, you can go big and then launch the picker from there. Because we think this is more important. It is more important to let the user complete their scenario than to leave them wondering, oh, I wonder why the 3 other buttons are there but the 4th one's not. I have no idea. And that could be very confusing. And before I go further, I know this is super attractive. Like, this is a very powerful. This is an interest. Like, you get to resize a user's app. This is the only time an app can decide how much screen real estate they have. However, I want you to be very careful about when you use this, because there is no way for you to go back small. And the other thing is we really want to make sure that we put the user in control. Just imagine I'm using this app, and if every time I interact with something in that app, it made my app bigger, I'll be very frustrated because I wanted the other app that was beside it bigger, and every time I played with you or used you, you made my other app small. I would be very frustrated. So make sure you do put the user in control when you're using programmatic unsnapping. Cool. And so, as I mentioned, just a summary of what I said before, resizing generally should not make features disappear. Strive to have feature parity across all view states, which includes the snap state. So now that we've gone over the high-level principles of thinking about your snap state, the next question you would have is how to actually design it. Well, there are 3 main steps that I'm going to go through. The first one is start early. So this is interesting because Jason actually mentioned it earlier as well about animations. This is true for snapping as well. What I've noticed when I've been, in my experience with working with partners is that it is much easier to plan for it. It is really hard once you've developed, kind of completely built your full screen landscape view and then retroactively try to stuff the snap view in there. It is much easier if you start planning for it in your planning stages, when you're thinking about how the navigation model works in your app, or what other pages are within your app. Just have at the back of your mind. You don't have to design it right away. Just have at the back of your mind, what would this be like snapped? So some questions you can have while you're planning your app, like for every page that I have, what would this be? What would it look like if I snap it now? Because remember, the user can snap you at any time, and so for all the pages that you have, make sure there's something to display. When you're thinking about where all the different pieces are going within your app, think about where would it go when I'm snapped now? Would I make it smaller? Would I maybe decide that this is not as important, I'm just going to remove it, it's more peripheral. And if your content is backed by a service, think about what you need to do in the service to make sure that you can properly support this state. So examples of that is maybe you're a super image heavy app in kind of the big views. Maybe you have to serve up smaller images for the snap view and make sure your service actually provides that. Or maybe you turn from a very image heavy view to a more text view in the snap state due to screen real estate. The next step is then to identify all your pages. So for this part of the presentation, I'm just going to walk through an app that you guys were introduced to earlier, which was Food with Friends, and try to walk you through how to think about the snap state for that app. And so if you remember from session 2, I'm just going to recap. You guys designed a set of hub pages, section pages, and detail pages within this app. And so the next step we want to do then is to make sure we tailor each page for the snap view. Now, I know this sounds like a lot of work. The good news is the snap view is always 320 pixels wide, which means that there is a specific width that you can target and make beautiful. you know exactly how much width you have to work with, so you know what size fonts that you can use, what size images that you can use, and what size controls that you can use to fit into this state. And I know it seems like there's not a lot of space to work with in this in this kind of view state. However, 320 pixels is not uncommon for mobile applications. And as we know, mobile has done a lot of good things, and there are a lot of interesting apps that came out in the mobile space. So this is not something that we're unfamiliar with. So let's start with the Food with Friends hub page and try to design a snap view for that. So as you can see here, there are 4 sections. There's the Tonight section, there's the Friends wish list section, there's My wish list, and finally the All Restaurants page. When we snap it, we want to make sure that we preserve the context and state. And so you notice the same content is there. Tonight is still there. Friends wish list, My wish list, and finally all restaurants. The next thing we did, if you haven't already noticed, is that it pans vertically. This is, we found that this is much more user-friendly for this long and skinny, tall and skinny aspect ratio. It's much easier to pan along the longer side of the app. And finally, what we did was we changed the header font so that we make sure there's enough characters that you can see within this narrow view. And we also actually decreased the back button. And then we just relayed out the item templates to better fit this aspect ratio. And David actually later is going to call out kind of what kind of things. There are a lot of tools and controls available for you to actually do this pretty easily, especially on the web if you're familiar with media queries. Now, the second principle that we have was that we want to strive for feature parity. And so we want to make sure that the same set of app commands that were available in the hub page is also available in the snap view of this page. And just to recap, because it was like 4 hours ago, in the hub page, if you select an item in the Tonight page, in the Tonight section, what you'll get is an app bar that shows you a list of commands to respond to it, and then as well as a global command to start a new plan. And so when you snap, we want to make sure we keep the same set of commands. Now, what's interesting here is that we drop the labels and decrease the padding. And this has been our guidance for what you should do with the app bar in the snap state, because we want to make sure that there is sufficient room for you to fit enough commands in there to match whatever you had in the bigger states. Now let's go to a different page within Food with Friends, which is the All Restaurant section page, the list view of that page. Again, recapping what we had there before, we had the ability to toggle between the map view and the list view, some filtering and sorting commands, and finally, again, the global new plans command. In the snap view, again, we would just drop the labels, decrease the padding between them, and fit them all into the app bar. This is also a good time to call out that 5 commands is the maximum that we can fit in one row. However, you can go up to 2 rows, so you can fit up to 10 commands within the app bar in the snap state. So now we move on to the map view of the restaurant section page. Again, the app bar looks slightly different, so I'll go over it again. There are still the toggles that let you toggles between list view and map view. So list view will get you back to the page that we saw before. There's slightly different filtering controls. There's the filter control, but because it's a map, we also have an additional command that lets you pinpoint where you are right now. And then there's the global command. So this gets interesting when you snap it. We realize that there's actually an extra button here, an extra button for an extra row. Now, there are a couple of things that we can do here. We can put it on a different row, which is acceptable. But it's kind of weird because new plan is a global command, right? It'd be really nice to have it in the same spot for all, like in the same spot in the app bar for all pages within the app. It'd be very weird for this particular page that the global new plan command is on the upper row. And so, let's be clever here. What can we do? Well, we'll notice that there is a command that actually doesn't really do anything. There's the maps command. All it does is it shows you where you are right now. And so what if we can just remove it and leave the command that lets you go to the other view? And so this is what we did for this particular example. We decided to drop the command that doesn't really do anything and just shows you where you are. And now we can fit it all and still get the benefit of having the global command be a consistent spot. And because we updated this in the in the map view, we should go back and make sure we also update it in the list view, because it'd be very weird to have both in the list view and not in the map view. And so in the list view, we'll drop the one that, that doesn't really do anything, and then just shift it accordingly so that it matches the app bar and the full screen view. And finally, we get to the restaurant detail page, which is actually one of the easier pages compared to what we just saw. Again, just reflow the page to pan vertically, and then keep the same app bar commands, and drop the labels and decrease the padding. And so just a summary of some recommended practices when you're designing snap view layouts. In general, like I said, we want you to pan vertically because we think that that is a much more user-friendly way to get to a lot of content in this long and skinny aspect ratio. Make sure you update header fonts, images, and item templates to fit into this particular aspect ratio, this fixed width. Remove labels and decrease padding in your app bar. If you use the app bar control, this actually comes to you for free. And finally, if it makes sense, collapse command sets in the app bar if necessary. So that was just one example of one way to design a snap view layout. Here are just some other quick ones that I'm going to walk through. For example, let's just go back for a second. For example, if you have multiple column layouts, one way to do it is to stack these multiple column layouts. And so mail is a very good example of that. You'll notice they have metadata on one side, content on the other. And so when they snap it, they actually just stacked it on top of one another. Another way to deal with multiple column layouts is, just showing one column at a time as opposed to stacking it. So here's mail again, our very good partner, showing accounts and folders, the folder content, and actually the email content. And when you snap it, they show just one column at a time and allow you to navigate between these columns. So if you press the back button, you go up one level to the folder content. If you press the back button again, you get to up one level to the accounts and folders content. And then again, you can drill back down the other way. And so tailoring and designing for the snap view will make your snap view much more usable to the user. And having a snap view that is well designed will make your app that much more desirable for the user, because remember, now I can use your app alongside any other app, whether it is related to the same scenario or completely separate. Just imagine, I don't know, a simple app like calculator. If there's a calculator that I can use with any other app, and a calculator app that I can't, I have to use it in the big screen, I'm much more likely to use the one that I can use with any other app, whether it be Excel on the desktop or like some mortgage calculator app. So we really want you to think hard about this app, because the fact that you can design your snap view will enable a lot of multitasking scenarios for the user. So with that, I'm going to hand the microphone over to David, who will talk to you about how you can scale beautifully.
All right. Hello, everyone, here in the room and online. I'm David Washington. I work on user experience in Windows. I work on how Windows scales to different screens and pixel densities. I've also worked on Windows Explorer and some of our file access APIs in Windows 7 and in Windows 8. So, what are we going to be talking to you about for the rest of this session? I'm going to start off by talking about screen size, how your app can adapt and scale to the different screen sizes. And then Justin is going to finish off by talking about pixel density. So screen sizes, a lot of us are familiar with. Any of your apps can run on a tablet or a laptop or a desktop. And as the screen size increases, you have more space that your app can make consideration for. Also, a concept that's not as many people are familiar with is pixel density. All these new screens are coming out with smaller and smaller pixels that are more dense, that look beautiful, and your app can take advantage of that. But first of all, why do you care? Why are you going to stick around on the webcast or stick around in this meeting and watch the rest of this? Well, for screen size, it really comes down to reach. Shireen mentioned this in the beginning, there are literally hundreds of millions of screens that your app can run on. You could stop and design it for 1366 and call it good and just walk home, but you're basically leaving money on the table. There's hundreds of millions of PCs that your app could look great on. Second, for pixel density, when people bring home these new high pixel density tablets that look beautiful and they run your apps on it and it looks beautiful and crisp and rich, then they're going to thank you for that. It's going to be a great experience for them. So it's really worth your time. We understand that all of these considerations are just another thing to add to your list of things to consider, but it's really worth your time. And hopefully, throughout the rest of this talk, we can show you how, with a little bit of effort and a little bit of thought, you can do it quite simply. So, starting off with screen sizes. The minimum resolution that your application can run on is 1024 by 768. And this seems pretty pedantic on the outset, but actually it's pretty important. We promise that we'll never size your app to be any smaller than this resolution. Of course, there's the snap view that Shireen talked about, but that's a very custom, fixed, predefined size. But you don't have to worry about all the crazy intermediate netbook sizes. It's really 1024 by 768. We won't even launch the app if your screen resolution is any lower. And then if you're going to start designing your app anywhere, we have been talking a lot about 1366 by 768. And we didn't just pull this number out of a hat. It's widescreen. It's great. We're seeing a lot of tablets with this aspect ratio. But also, it happens to be the most common screen resolution out in the marketplace today. So when we look at all of our usage data for Windows 7 and our forecast data for the devices that are shipping with Windows 8, we see 1366 by 768 as currently being the most common resolution. And there's a blog post on the Building Windows 8 blog that shows some more of that data if you want to take a look at it. But this is a great place to start, and all the templates and tools have been designed to help you start here. So with this example app here, this is like a news app. We've seen it in some of the other pictures. What would happen on a larger screen? So this is just a sample here. Well, of course, on a news app, in this news app, if I am on my laptop, which happens to be a 13-inch screen with 1400 by 1050, has a little bit different shape, I can actually fit another row of news articles. And you're starting to get an idea for, as the screen size increases, it's really the canvas increasing. You're getting more space for your app to draw. And then, of course, if you have a desktop monitor or an all-in-one, you can fit even more. Here I can fit way more articles, all the way up to a really crazy big monitor, a 30-inch monitor. This is a lot going on. You may not want your app to look like this, but this is just to demonstrate how on larger screens you can really make use of that space. So just to recap some of the key things for you to remember, there's the min resolution. It's 1024 by 768. And handily, on that most common resolution of 1366 by 768, it's also the size of your app if another app is snapped. So it's not like you have to think of another kind of random size. If you have your snap view on one side, the other side is 1024 by 768 on the most common resolution. So it's 1024 is the minimum. Good place to start is 1366. And then you want to think about how your apps can take advantage of that added screen real estate. We're thinking of ways that we can make it so the user thanks you for taking advantage of that larger screen that they bought. And we want to look at ways that we can be as immersive as possible on these larger screens. So you may be thinking, okay, I'm just going to ship my app and be done. What happens if I do nothing? This may not happen exactly to your app, but it's possible that if you ship it in the store and someone runs it, you may be in a situation where you have a big empty space or an ugly space or something that you didn't design for. And you don't want to get into a situation where you publish your app to the store and then like 20 people, not 20, but like all the people with tablets are really excited about it and give you a high rating. But then there's like all the like millions of people with laptops or desktop who try it out who say, man, this is like not great. I don't understand why they didn't think about me. So it's an opportunity for you to say, well, what can I do to think about these larger screens? And it's not necessarily, you're not designing a different app or a different version or a different package. It's the same app, and actually with just a little bit of thought when you're designing your app, you can define the rules for your layout in such a way that it will work regardless of the screen size. And Windows 8, the platform, offers two design approaches that we kind of offer all applications here. One is what we call the adaptive approach. So those of you who are familiar with adaptive web design, very similar concept. This is where you're considering the proportions of your app, and you're looking at the different regions and determining which regions adapt and scale and which regions remain fixed. So here, you're considering how your app will reflow and reshape on larger screens. And then there's a fixed approach, and we also realize there's a lot of games, educational style apps that are highly rendered, that may be made up of exclusively bitmaps in some cases. And here we realize it may not even be possible for you to adapt or to reflow that content. So in this case, we have a fixed layout style, and it's a template in Visual Studio or a control that you can apply to your app that will scale it to stretch to fit any screen. And I'll show you how that works as well. So for adaptive, what does it mean? And this isn't really necessarily like one control that you go use. It's really a way of thinking. It's really about considering your layout. I've seen a lot of, in all the other talks today, it's about, okay, let me spend some time to think about what I would look like in Snap, or think about my animation. So this is kind of a very similar thing. Spend some time to think about how your app will adapt and what the proportions and what the regions of that app is. So here's one of our templates. If we were trying to design this to be adaptive, the first thing that we do is we design a wireframe for the page. And you can rinse and repeat this whole process for every page in your layout. Once you design the wireframe, you look at the header, the description, the content. You look at these individual regions, and you determine which regions remain fixed in the X and Y axis, which regions are just going to stay the same, and which regions adapt. So here, the header is always going to remain fixed in that upper left-hand corner. Regardless of how big the screen is, it's always going to be the same fixed amount of pixels from the top of the screen. Same thing with this description pane. It's always going to be the same amount of fixed pixels from the left. That's some fixed size that we determine. However, this content region, I decided this is going to adapt, and it's going to expand and get bigger on larger screens. But then you may be asking yourself, well, once I figure out what region I want to adapt, or what multiple regions I want to adapt, how do I actually make use of that space? Like, if I give you a bigger piece of paper, what do I go do to fill that bigger piece of paper? And there's these three sub-approaches that you can use to make use of the space. And these are things that we've done internally inside of our apps, and also some things that we've seen other apps do. So first, you can show more content. So here's a pretty simple example. On the left, I have a map. And you can see, I can see part of the Puget Sound area around Microsoft here. But on a larger screen, I can just show more map. If you have a bigger screen, you can show more content, show more map. And of course, we've seen, I didn't use that example here, but we've seen all of these list views where you have tons of items. You can always show more items. And that's a situation where I have this massive monitor. You can give me more for it by putting more content on it. The second technique is to make content bigger. So here, this happens to be what the store is doing. And you can see that the store header remains fixed. That part of their grid remains in the same place. However, this item content region where they have these big nicely designed hero graphics where they wouldn't necessarily want to reflow them or to bring in more content, they actually make that part bigger. So just to look at here, on the left, I'm just going to highlight with my mouse, we have our smaller screen where the store remains fixed, and we have the item area. And then on a larger screen, we just stretch all of those graphics so they're bigger on the larger screen. And in this case, the store is in pretty good shape because all of you are providing larger graphics for the high DPI cases so they can reuse them for large screens. And we'll talk about high DPI when Justin gets up here. Another approach that we evaluated is you can always manage the white space. Of course, in this case, if you did nothing, then the white space would just come off of the bottom of this view. So you just have empty white space on the bottom. But as long as you make it look as long as you make it clear to the user that you've thought of them, even if you can't make things bigger or you can't bring in more content, that's not necessarily a bad thing. Sometimes space can actually be very beautiful and can enhance your experience. So this is something we considered for the store. We didn't end up doing, but it's an example of a way that you can still look designed and still look great, even though you're not bringing in more content. So those are 3 approaches you can use. However, just a big pitch for all the work that we've done in the tools and in the controls, we've done a lot of the heavy lifting for you. If you're using our templates and controls, then a lot of this thinking has been done for you. So here is one of the standard grid templates that comes with Visual Studio. On a larger screen, it just brings in more items into the list view. And the list view control is another example of something that does this work for you. Also, there's the multi-column text control. It brings in more columns if there's more space. On the smaller screen, we only get about 2 columns. On the big screen, we get 3 columns. So that's the adaptive approach. And there's a ton more documentation online. But the biggest takeaway for you there is if you want to be adaptive, think about how your layout will respond. So fixed apps are a little different. This is for games. It's for these highly rendered apps with tons of graphics where you can't necessarily reflow everything. And the way this works is you specify a fixed size. So for your whole app, you say, OK, I want to be 1366 by 768. I've used fixed pixels all over the place. And then, of course, you do the snap view, and you do your portrait view, and your 4x3 fill view. But once you specify your app in these fixed pixels, then Windows will automatically scale it to larger screens. So I can show you here. Here's a game. This is my office, actually. I've got a tablet, a laptop, and a desktop. The guy in my team who wrote this app, Xiao, designed it for 1366 by 768. He's got all this crazy JavaScript math that's calculating like where all the buttons are because that's the way he happened to write this app. And then on a larger screen, it just gets bigger. So you can see on the desktop monitor, it's a really big app. On the laptop, it is a little bit smaller. And on the tablet, it's at its design size. And the one thing to note here is if your app is a different aspect ratio than the screen, then you get to control the letterboxing behavior. Because, of course, you never would want to stretch images in an aspect ratio that's different than your app. So Windows will automatically letterbox it. Just by specifying the background color or image for your app, you get that letterboxing behavior automatically. One thing to consider here is you're taking those small fixed pixel sizes and then they're getting scaled up on larger screens for the fixed app approach. This won't happen with the adaptive approach, but with the fixed app approach, they're actually getting scaled on larger screens. So you need to think about those images. Obviously, if you use vector graphics, boom, those are going to look great. But if you're using bitmaps, we recommend either looking at the screen size and swapping out the image on a larger screen, or you can just start with larger images that get scaled down on your small screen, and then that are the design size on the larger screen. So this is another consideration for fixed apps. Usually, if you're building a fixed app, you know what kind of app you are. You know you fall into that category. Something about fixed apps, it's not for everyone. Because remember, we want users to thank you for their experience. So let's say you're building an email app. If your email app is like, each email is friggin' huge on your like big monitor, then you're going to be like, that's weird. Like on my big monitor, I want to see more emails. That's why I bought the big monitor. So it's really about these game scenarios and these education scenarios. So that was large screens. We're going to bring up Justin, and he's going to finish off this talk and talk about pixel density. Thanks a lot.
Great, thanks, David. So my name is Justin Cooperman. I'm a program manager on the user experience team, and I work with David on scaling. And I'm going to be talking about the second important consideration to make when you're thinking about scaling, and that's pixel density. And pixel density is a hot topic right now because there's going to be a lot of new devices coming out. They're ultra high DPI. A lot of new sexy devices, new tablets, things like that. DPI, or dots per inch, is an industry term used to talk about pixel density. So what's all this about? Well, pixel density is literally how many pixels can a device pack into physical real estate. So here we have two devices, and they're actually the same physical size. They're both 11.6 diagonal inches. The screen on the right is a 1080p device, however, and you might be thinking, that's awesome, it has more pixels, it's great. Most people would say this is a better device. But if there's no adjustments made, there's a problem here. The problem is, as pixel density increases, things get physically smaller. This is especially a problem for Windows 8 because a lot of the devices will be touch devices. It's sometimes hard to touch things when they're physically smaller. So this is a Tweetorama app from Windows Developer Preview. And you can see that this post button, let's say it was 60 by 20 pixels, on the 1080p device, it's actually physically smaller. It might be hard to touch. So what are you going to do about this? Well, the great news is you don't have to do anything. With Windows 8, we have our scaling platform, which scales things up automatically for you. It's great. It's really convenient. Things are crisp and it's easier. Things maintain touchability as DPI increases. You can see here that the header is much more crisp on a 1080p device, and this is what your users are going to expect, especially because they paid the money for these high DPI devices. So how does Windows do this? How does it do this automatic scaling for you? Well, what we do is we scale things up depending on the DPI of the device because we want to maintain touchability and make sure that things like images and text retain their physical size. There are three system scaling percentages that we have: the 100% scale factor, the 140% scale factor, and the 180% scale factor. These are all aligned to devices that will be in the ecosystem. So devices that are out today would be in the 100% scale factor. But then there's 1080p devices that will be coming out and quad XGA devices that will be coming out. And we make sure that these devices fall into one of these categories so that Windows can scale things up if needed on these different devices. So what are you going to do to design for these things, and how are you going to think about pixel density? Well, as I mentioned, our layouts, images and text and things like that are going to scale up automatically, and that's great. So you don't have to do anything about that. Physical size will be retained, and that's wonderful. However, as you stretch an image, you probably are aware it gets blurry, and that's not desirable. So we want your images to be really crisp and beautiful. To do that, we need to either have people using vector art, which is going to scale nicely automatically, or developers need to provide multiple versions of images so that as we hit these different scale percentages, we're able to actually swap in these different images so they look beautiful on these devices. So how does that work for developers? Well, it's actually really easy, and we wanted to do this to make sure it was super easy for people to develop for these high DPI devices. What you do is you can just specify an image in your app, just as you would, think to do anyway, which would be adding something like projector.jpg to your app. What you would do then on the back end is just simply add 3 versions of this image to your package, and Windows is automatically going to pick the right one for your app, depending on what device the user is running on. So if the user has a really ultra high DPI device and you've added 3 versions of your projector image to your app package, Windows is going to pick the 180% one if it needs to be picked for that device, and it will look beautiful. It won't be stretched up and blurry. It will look nice because that image was designed for that size. There's also another thing to think about when you're designing for pixel density, and that's layouts and the typographic grid. Chantal talked a little bit about the grid system. The 20 and 5 pixel grid system is really nice, not only because it looks aesthetically beautiful and things will look very laid out nicely and proportional. It's also nice because your layout will not experience any pixel rounding issues or pixel shifting. The reason for that is the 20 and 5 pixel system works nicely. You see here on the 140% and 180% scale factors, there's no rounding. So your layout is going to stay proportional on all different DPI devices, and that's really nice. And it's kind of like an added bonus for really designing your app to align to the grid system. So to recap what David and I talked about, think about when you're thinking about scaling. David came up here and talked about screen sizes and what to think about as users start running your apps on screens that are huge, because there's going to be a myriad of devices in the Windows 8 ecosystem. There's a few considerations to make, a few choices you have. You can either make an adaptive app, make sure things are getting bigger the way you want them to, and you're going to be thinking in proportions. Or you can, if you have a game or an educational app, you might want to choose a fixed app. And in that way, Windows will just make your app larger and letterboxed on larger screens. The second thing I just talked about is pixel density. On these really hot, cool new devices that are coming out, they're going to be really high DPI devices. Make sure that images look great. You're either going to have to provide vector art, which we talked about, use SVG images, or provide multiple images by adding just multiple versions of the resource in your package. Windows will select the right one for you automatically. And then again, use the grid system, the 20 and 5 pixel grid system, because it's really convenient. Not only it will make your app look great, but also there will be no pixel shifting, and things will feel the way that you wanted them to, and look the way you designed them. So with that, I think I'm going to wrap this up and invite David and Shering back up to do some Q&A here. So thanks a lot. Appreciate it.
Great. Thank you, guys. So first, are there any questions in the room, folks? Yeah.
When you're in SnapView, and if you're leveraging the top sort of navigational bar, how does that work in SnapView?
Is it the one that we're seeing in Bing? Is that? Oh, the question is, what do you, if you're leveraging the top navigational bar, how does that work in the Snap View? So I'm not sure which piece you're referring to. Is it the app bar that you see in Bing right now? Because I've been most familiar with the bottom app bar.
Yeah, when it comes in from the top, or like in
are they boxes?
Select,
oh, okay.
Where you can jump between sections within an application, like if you have a horizontal application.
So in this case, we've actually had we would also pan this vertically. So you can imagine bringing that in, and then you would also pan that vertically. You would stack the contents vertically instead of doing it horizontally. Basically, we change all the panning direction for the snap state. Yeah.
Cool. So just going to a question from email from Aaron in Seattle, who says, I'm wondering what app will Charmbar acknowledge when there is an app snap view, snap left, snap right, fill view left, or fill view right?
Sorry, can you repeat the question?
So he's wondering what app will Charmbar acknowledge when there's an app in snap state.
Okay, the question is, which app will the charms bar acknowledge when there is an app in the snap state? We acknowledge, it operates on the bigger app, the filled app.
Any other questions in the room?
Yeah. For fixed app, you guys talked a little bit about the smallest resolution. You're creating images for a fixed app that are going to scale. What's the largest resolution or screen size that's kind of reasonable to plan for?
Great question. Just to re-say the question, what's the largest resolution that apps should plan for? And if you're building a fixed app, how should you, what size images should you provide to make sure that they'll look good? So in general, the largest screen resolution that we see and that you probably have to plan for is a 2560 by 1440 30-inch. And there's all these larger screens too, like 70 inches, but in general they don't have more pixels. So really that 30-inch 2560 by 1600 is the largest. And as a guideline, we say about 2x images size for fixed apps. So if you save out 2x images, then that will cover a lot. That covers you up to that 2560 by 1600, and it has a little bit of fudge room on the high end. So that's a good guideline to use.
So I'll take one more from email and come back to you. So Greg from New York asks, says, I have an HP touch smart showing Windows 8 apps currently, and on high resolution screens, Windows 8 layout of apps sometimes gets a bit funky, and I think you saw some examples of that. I worry about the super high res screens we'll be using next year, in particular with the fixed width snap view. Do you think that could be a problem? He asks. So it's like a 320 pixels and having that large screen real estate?
So, yeah, just to recap the question, it was a kind of a compound question. So, and a few statements, I guess, too. The person online has a HP TouchSmart with a large screen, and he's been using some apps, and they're not taking advantage of the space, and he's wondering if that's a problem. And then the second half of the question is, if the snapped view is always fixed, then is that a problem that there's all this extra space that apps need to take care of? So I'll do my best to answer both those questions. So the first half of the question, do apps, apps aren't taking advantage of that extra space? Yes. So that's a call to action for developers. Hopefully the person who asked the question is a developer and can fix his app and make the best app for large screens. But really, it does take added thought by folks like you to actually make sure that the apps will adapt for these larger screens. Some users may enable this setting that can make everything bigger on system-wide, but in general, that's not an ideal experience. Again, if you have a large screen, you want to see more content on it. And the second question was around Snap. If apps have been designed to scale and to take advantage of these larger screens, then actually it's okay that Snap remains that fixed 320 pixels on the side, because the large app, the Fill app, will take advantage of all that other added space. So all the same things that Shireen was saying still apply. You may have a stock or finance app to watch all of your trades in action in the big screen, and then on the left you may be chatting with your broker about what things you want to make bids on. So all the same scenarios still apply, whether on a small screen or a large screen.
Yeah, so this might be a pointless question in the end, but so if it is, sorry. But the Windows, the store doesn't have a snap state. Is that intentional? And if so, why? Or is it just because it's like a developer preview?
Yeah, the question is, the Windows Store does not have a snap state. Is this intentional? It is not intentional. The store is still working on it. We are definitely hoping that they will support the snap state. This is not what we would use as the best example for how to design your snap state. Yeah.
Cool. And then going back to email, an email from Dennis. Email asks, is providing, and this is kind of going back to the previous question, is providing snap view required for Metro style apps? If so, what is the recommendation for an app in which less than full screen view doesn't really make sense? So think of a game, for example, and maybe a game should be paused. Is that the advice and guidance that you would give?
Okay, so just to summarize the question, is the snap state required? And if there is an app that doesn't really work well in the snap state, like a game, what can they do there? So snap state is required in that the user can do this to your app at any time. So if you're okay with your app, have all your controls and scroll bars looking very awkward, then that is something that you can decide to do. But our call to action to you is that if you can really design your snap state, you provide so much more value to the user in the multitasking scenarios. And back to the game question, there are actually surprisingly a lot of games that can work in the snap state. One that I've been playing with in the store, I think in the consumer preview, was Wordament. They actually reflowed their content so that you can actually play the game on the side while you're doing something else. So I think it really depends on the game. If there are games that really require all that space, pausing is one way to do it. And you can imagine having a pause button when you snap and then having a resume button that lets you go big and continue to play the game.
Any other questions in the room? Okay. I have another one from Fabio. You may remember him. He asks, can I launch another app from my app in SnapView? For example, if I click on an email while reading the news, would it open the email app in SnapView?
No, you cannot launch. Oh, the question is, can I launch directly into the SnapView? No, the SnapView is a very deliberate user action. It is actually one view state that lets you stay on screen. Every other activation always replaces the bigger app. While the Snapped app always stays on screen. So we feel like this is a very privileged spot to be in, and so we do not want apps to be able to get into this state. It is the user who puts you in that state.
Okay. Thank you. Any more questions in the room? Okay, so coming back to email, Brian asks, he's a little confused why SnapView is limited to 320 pixels. Given so much of the presentation was focused on scaling, so what was the decision there? What's the logic behind the 320 pixel?
I might be able to speak on it a little bit. So Shireen can follow up, but just to rephrase the question, what was the logic behind choosing this fixed 320 pixels rather than making it adapt, especially after, David, you talked about all this stuff with scaling? So totally valid question. So I alluded to this a little bit in the beginning of the scaling talk, but those of you who are kind of developing and designing layouts, it's very tricky to start designing layouts that are adaptive once you're going smaller. You can get into a situation where you might have to redesign your layout at each step. So like 1024 by 768 might look good, but then in order to fit, like you added a lot of nice content and layout and controls into that layout, and then like just going a little bit smaller might require a lot more thinking. So by making the snap view fixed, it allows you to really tailor and pack a lot of useful content and really design it to be great without really thinking about the adaptive state, because we know how hard that is. And then 320 pixels is a common design. I think Shireen mentioned this. This is a common width that's designed on mobile phones. So it's something that we know people have used and designed for.
David actually took the words out of my mouth.
And the other cool thing about 320 pixels is the other side of that on a 1366 by 768 screen is 1024 pixels, if you take into account our 22 pixel little resizer. So they're very very thoughtfully designed sizes that makes everything kind of work together harmoniously.
And then sticking to the 320 pixel theme questions from the Twitterverse, Martin asks, does the 320 snap view adapt to high pixel density, or will touch targets become too small?
Yep, so the question was 320 pixel in the snap region, will this also adapt to high pixel density, high DPI devices? Yes, the answer is yes. So if you have an ultra high DPI device, it's also going to experience these scale percentages. So depending on what scale percentage is at, if the app has provided multiple versions of the images or using vector art, your things will look beautiful, things will look crisp, and things will be scaled up the same way as I showed before a full view of the app would.
Any further questions from the room? If you could ask the Twitterverse if there are any other questions before we lose you guys.
Are there any other questions in the Twitterverse before we take off?
It's like quiet down a little bit now, so cool. Well, thank you very much, guys.
Thanks a lot.